Computer Science and Programming Language Java. Today we will discuss the notion of sorting and specifically the technique that is named selection sort. And to illustrate this idea, I will use several examples. I will begin with an example that happened to me. I once participated in a race, a running race, which competitors run, and at the end of this race we were all seated randomly in some auditorium, in some hall, and each sat wherever he or she wanted, and the winners were announced, and there were 3 winners according to age, and the 3 winners were announced, and they were asked to come to the front, to the stage, and to receive their medals. And this is what happened at that case. Luckily, I also was one of the winners. I won 2nd place, and I was named, and I moved from my seat, which was a random seat in the sport hall, whatever the number of the seat was. Let's say the seat was number 42. It was completely random wherever I sat. But then I went to the front of the stage, and I stood at the position of number 2, the position on the stage that made it public that I was declared as the 2nd place winner. And the reason I mentioned that those spots on the stage that were numbered 1, 2, and 3 were already there naturally, and I just walked and stood on them. And the reason I mention it is because that one of the things that make this kind of technique to sort different from other varieties of sorting that are available in programming languages is because this kind of sort, which we call selection sort, is a kind of sort that whenever we make this assessment and we decide that some object or person is deemed to be number 1 or number 2 because of his or her qualities or achievements, wherever we place this object in its designated final position. In my case, it was the spot of number 2, the person that got the 2nd place a medal. So this was my final position, and I was called there, I stood there, and this is where I stayed. And this is a bit different from other techniques of sorting, which I also made other videos about them. But interestingly, when we look at this example, it is important that we notice that there are all kinds of numbers in this example. Well, when I was sitting on my chair in the hall before I was called to the stage, well, I had whatever number on the seat that I was sitting on. It was just a random number, because when we in our homework, as we study computer science and programming language, when we get our homework, we receive an array. Maybe we build this array ourselves, and this array include objects that are randomly located in it. It has no meaning where they are at the moment. The fact that I was sitting in the auditorium on this big hall, and I was seated on a chair that its number was 42, it has no meaning. But when I went to the other part of this auditorium, and I stood on my position of the final decision of the winner, and it was marked as a 2nd place, this had some meaning, this index of number 1 or number 2 or number 3, because it shows what is my quality, that I am the 2nd best in this specific running race. But it's interesting that another very important number or value in all of this example is what was my score when I ran. how many minutes it took me to finish this race, because my score as a runner dictated that I'm the one that is going to be declared as the second best winner. So it does matter that to me it took to finish this race, whether it was a 5-kilometer race or 10 kilometers or whatever race it was, how many minutes it took me to finish it. Because according to this number, it's going to be decided if I'm second place or first place or a much lower place. So it's important to see this distinguish between those numbers that represent my place prior to this sorting action, which is in the auditorium where I sat before the medals were granted, or if I'm looking at the indices of the places after the sorting, which is first place, second place, third place of the race, or if I'm looking at a number that shows my inner quality, my value in this respect, in this regard, which is what was my achievement when I ran? How long did it took me? And we can see in the code of sorting that we see all of those numbers, and it is important to understand the distinguish between what each number means. Is it just the index of where an object is located in the array, or does it mean its own inner quality, which according to it we are going to perform this sorting? And another interesting thing to notice is that when I left my place at those random chairs where I was seated before, and I moved to the place where I got the medal, so it's being understood from this example that the hall that we were at was quite large, and there was room to move around. Well, in computers, it's a bit different. Well, a lot of thinking and planning in writing code goes to making the use of space most efficient. So it would be more appropriate in a code that we are writing, and if we are using an array, that there will not be empty spots or empty spaces such as were in this running race. When I moved from my seat at the auditorium, I left it vacant and I went to another part of the room, but actually it's going to be all at the same space. And it's just that before I began to do the sorting, all of the objects in the array were unsorted and they were randomly located. And as I go ahead and I perform the sorting and I decide who is first place, who is second place, I dedicate some of the place in my array to the sorted objects. And as time goes by and I have more objects that are sorted, there are less objects and less space that is dedicated to the portion that is not sorted yet. And to illustrate it even further, I will give another example, also from the sports field. And at the past, I used to train in martial arts. And in the beginning of each training, we were doing some warm up, and the teacher, he or the leader of the group, would ask us to do a few actions to warm up. For example, he would ask each of us he would ask all of the group to perform about 50 push-ups. And each would do that. We would all do that together on the mattresses. And everyone that finished this amount of push-ups that he was requested to do, we were all requested to do the same amount of push-ups. Whoever finished just moved and just placed himself or herself beside the wall. And we will all just form a line. Each one that finished to do his or her push-ups would sit beside the wall and wait to his fellows to join him. And interestingly, the first one that finished to do his or her push-ups and sat by the wall, and let's say each are sitting one after another on the same chronological order that they finished, each one, the first one that sat there by the wall, he was or she was the one who was the most fit. He was the one that finished the push-up first with at the least amount of time. He had the best biceps or the best triceps or the best movement or body physical strength. He or she finished first. The push-ups. So you can see that as the time goes by, there were less people that were doing push-ups because they were finishing their push-ups, and they were sitting one next to each other beside the wall, and there was forming some order. And the first one was the one with the best physical shape. The second one was the one also with good physical shape, but a bit less than the first one, and so on, because this reflected their ability. And as we said before, that in programming we are trying to be efficient with space. So let's just assume that this studio of martial arts is quite small, and each person that is sitting beside the wall after he or she finished to do his or her push-ups, actually, as the line goes and grows, it diminishes from the place of where the people were doing push-ups, where they were just randomly doing the push-ups with no order. So it's like it's one or the other. It's either all of the people are here in the area of the mattresses, and then as time goes by, more are near the wall. They finish to do their push-ups, but it's kind of taking the space of where before was the mattresses. So it's like kind of switching the places between another, because as I said, we do not have free space. We try to, because it would be more efficient not to have free space, but it's kind of alternating from both of those groups. So and as I am speaking about this thing, and I'm also showing that there is a difference between the numbers that are reflecting the indexes of where the children, the players are located, and to contrast it with numbers that reflect their inner value or inner ability or inner fitness. It's, as an example, I can also give the notion that when I look and read articles in the internet or and I notice, or in newspaper, and I notice that there are many articles that has the aim to present, for example, the 10 most richest, wealthiest people in the world, or the 10 most rich nations in the world, or the 10 most beautiful people in the world. And then you can see that there is a list of people or nations or cars, and they are listed from 1 to 10. But next to those numbers, there is other values that shows their intrinsic value or ability, something that shows how good they are, or how fast they are, or how rich they are. And this is also many times being showed or being presented with some numeric value. This person is number 1, the richest man in the world, because his personal value in dollars is such and such $1 billion, and so on. So this also helps us see this distinction between what kind of value are we now looking at. Are we looking at a value of this object, which shows its character, its advantages, its prowess, or are we looking at numbers that represents the indexes, whether it's before or after sorting, whether it's just random or it shows this sorting and who is the best and who is the worst, and so on. So another notion that comes in when we're talking about selection sort is the idea of loops, for loops. And specifically when we're talking about this kind of sort that this video is concentrating on, and this is the selection sort. Selection sort has an outer loop and an inner loop, and now I'm going to explain what those loops mean. So in order to explain it in an understandable way, I will again take an example from the field of sports once more. And the field of sports that I will now choose is baseball. So I have learned that there are scouts in teams of colleges in the United States and all over the world actually. And those scouts want to find the best player of baseball and to recruit him or her to join their team at the college, to receive a scholarship, and to join their team. And so let's say that there is a scout that is eligible to choose one good player each season, and to recruit that player to his college, to his college's team. So my scout person, this scouter, he has a contract. This is the contract, and he's going to sit in a play of some school, some middle school, and he's going to watch this game, and he's going to look at each of the players, and he's going to see and decide who is the best among them, and the one that is the best. This scouter is going to write his name here on this blank space on the contract, and he's going to go down to meet him and the player's parents after the game, and he's going to offer him a scholarship to come and play at his college. So, and this is going to happen each season, because each season the scouter can choose one player. But each season, when this scouter comes to the school and looks and observes the players, he's going to observe each and every player. So the scouter is going to look at each and every player and observe each of them. And if the team in front of him that he's observing has nine players, he's going to observe 9 people. So this is the inner loop. The inner loop says that he's going to observe this and this and this and each of the 9 players. So it's a loop. He's going to repeat this action of observing the players. And this is the inner loop. The outer loop is the fact that this scouter is going to do this process again next season. And next season, and next season. So each season is going to do this process again, and this is the outer loop. So now let's see what's going to happen. I'm the scouter, and this is season number 1. I'm going to look at the game of some middle school, some school, and I'm going to look at the team that has 9 people, and I want to choose the one that is the best of them. What does it mean the best? Maybe he's the fastest, maybe he has the most home runs, maybe he's the best, he catches the best, had the most catches of the ball, or some other numeric value that I can assess. So I'm beginning with the first player, and I'm looking at him or her, and let's say his name is Johnny. Now, Johnny is the first player that I'm assessing. And until now, because I only watched Johnny, I think Johnny is the best. Well, it's no wonder, because he's the only one that I checked till far. So I'm looking at Johnny, and he's the best that I've seen until now. So I am writing Johnny's name on the contract in the blank space. He's the best that I've seen so far. So I'm writing here Johnny. I wrote Johnny's name. Now I'm looking at the next player. I'm looking at Mark. Now I'm going to make an assessment. Is Mark better than the one that is already written here on my contract? Is he faster? Is he better? Is he more fit? Some other numeric assessment that I can make some comparison to the one that already I have his name here, Johnny. So after making this assessment, and by the way, this assessment is just an arithmetic simple check of is of bigger or smaller, or I can use some function that is called compare to, and I'm going to do another video on this comparison technique, but I'm doing some kind of comparison. Now, if I decide that Mark is not better than the one that already I have his name here on the contract, so I move on to the next player. So let's say Mark is not much better. I'm moving to the next player. I'm observing him or her. Let's say his name is Tommy. So I look at Tommy and I make this comparison to the one that his name is already here on my contract. And I say Mark is better than Johnny, or Tommy, sorry. Tommy is better than Johnny. If I compare them, he's better, he's faster, he's more athletic. So what I do is I take my eraser, I erase the name of Johnny, and I write instead of it the name of Tommy. Because Tommy is the best until now. And I continue to do that to each and every player. And if I find any player that is better than the one that has already his name on my contract, I erase the name that is already here on the contract, and I write the name of the one that I see that is better. And I do this until I finish all of those 9 players. And at the end of those 9 players, it's the end of this the one loop that I finished, one season. So at the end of this, of assessing all of the players in my team, I have here on my contract the name of the one that is the best. He is the best in the team. So he's the one that is number 1. And he's the one that I'm going to go down and offer a scholarship to. So I took this guy, let's say it was Tommy, that is the best, and I took him to the college. I recruited him. I gave him a scholarship. Next season, I, as the scouter, go back again to watch the other school and to find the best one in that team to recruit. That's the outer loop that I repeated. Now I come to the school. Now I don't have 9 team players. I only have 8 because one I already took last season. So among those 8 players, I'm going to choose the one that is the best. Of course, it's not going to be the one that I'm going to choose is only second best to Tommy that I took last season. But among the 8 people that are now on the field, he's going to be the best of them. So I'm going to do the same thing again. I'm going to look at the team. The first one of them is the best one I saw till now in this round. So I'm going to write his name here. And then I'm going to look at the other one and I'm going to assess, is he better or worse than the one that is written here? If he's worse, I'm going on to check the other one after him. If he's better, I'm going to write his name. And at the end of this round, I'm going to see what is written here on the contract. He is the person that I'm going to ask him to come with me to the college and give him a scholarship and sign him on the contract. And the next season, I will do this again. And at the end, this is quite like what we do in our code. But interestingly, when I gave this example, I was talking about players and I gave them names such as Tommy, Johnny, Mark, and so on. But many times when we look at objects, those objects do not have names such as myself or those other players. They are represented just by simple numbers. For example, in cases that a company that produces soft drinks wants to get a new drink to the market, and this company wants to assess and make sure that they want to know is their product going to be accepted well by the public. So they can make a line of cups, just like the cups that you see here in front of you, and give each of them a number. And we start in computer science from 0, 1, 2, 3, 4. We have 5 cups, and they would like the public or some volunteers to try them, those drinks, and give them some score, maybe decide their sweetness, if is it more sweet or less sweet, or more delicious or less delicious, some kind of quality that those drinks has, and to give those qualities maybe some kind of numeric scoring, some grading system. And now the company would like to sort all of those different beverages according to their favorability, how they were received by the public, or some other grading, like their sweetness or whatever. So as we see, we have here 5 cups, and as the examples that we did before. We will start from the first one. And the first one, which is numbered 0, it's the only one that I am checking till far. So right now, in my humble idea, this is the best. It is the most sweet, the most delicious. So since this is the only one that I checked till far, and it's the best until now, I can write not its name. It's not named Tony and not Johnny. It's the name of this beverage is number 0. So because this is the best one that I checked till far, I will write the number 0 here. It's like the contract of the scouter. And this will help me see which beverage is the best till far. So now I will move to the second one. This is this loop, like the scouter that checked all of the players. Now I'm going to check in this round all of those beverages and decide which is the best. So I already checked this one. Until now, this is the best. Now I'm going to check this one. And I will make some comparison, numerical comparison, or see arithmetically which one is bigger, or use the function compare to. I will compare it to the one that is already written here on the wall, on this note. And I will check if it's better, if it's bigger or smaller, or is it better than the one that's already here. Let's say it's not better. So we will move to the next one. And now I will check, is this one here, number 2, is it better than what's written here or not? Let's say that I'm making this comparison to the one that was in number 0, and I decide that this is better. It's more sweet, it's more favorable, more people liked it, has some kind of inner quality is better. So now that I know that this is better than the one that was written on the wall, I can erase. And I will write the number of the one that is better, number 2. And I will continue to do the same thing until the end. And if I finish this round and I look what I have in my contract, what I have on this wall, and I see the number that is written, the object that is in this index, it is the best. It is number 1. It is the winner of all of this group. So now I want to place it, as I was called after the running race to position myself in the position of the one that received a good score. Now I'm going to take this cup, which is the best. It's a number 2, and I already established that this is the best, and I want to put it in its final position, the final position that represents the fact that it was the best. It was number 1. It was the fabulous. So it's like the person that finished in the martial arts example, finished to do the push-ups the fastest among all of us. So he is number 1, and I want to put him here on the first spot. So what I want to do, because I'm going to start to sort my all of the objects, and I'm going to begin from here. So here is going to be the one that is the best, as the players of the martial arts that were all lined near the wall in an order according to how fast they finished the push-ups. So my wall starts from here. So I want the best cup, which is this one, to be placed here in this spot, which is the best. So I'm going to swap them. And now the one that was the best is here on the first one. So in my eyes, all of this portion, I will put this just so you will see which portion I'm discussing. All of the portion that is here is already sorted. Here we have the best, the one that already has their final position that shows their quality and their prowess. And all of these on this side, they were not sorted yet. So now we will go again and like the scout that come to the next season, now we will see who is the best among those 4 that are left and they are not sorted yet. So I will begin with the first one. The first one is the best one I tried until now in this round. Its number is 1. And I will write here 1. So this is the best until now. Now I will check this one. Is this one better than the one that is written here? Is it sweeter? Is it finer? Is it more popular? If not, I will move to the next one. If it is better, it's better than the one that is written here, then I will erase what is written here. And I will write what is written here. And so on, I will proceed. So on the end of this round, what is going to be written here is the one that is best among those four. It's not as good as this one, but it's second best. So let's say that this is the one, I said 2, so let's say this is the one that is the best, this round. So now I want to place it here, at the second place of the sorted portion of my array. So I will swap them. Now this portion here is already sorted. This is the first best, this is the second best. All of these three are not sorted yet. And in the next round, I'm going to find the best among them, and I'm going to place it here on the third position. So at the end, when I finish all this, and I'm going to do it this loop again and again, at the end we will be in a place that all of those 5 objects are sorted, and they are sorted according to their fitness, according to their inner quality, and in beginning from here and ending here, and everything is sorted. And as you can see, we did not use extra space. As I explained with my example of the martial arts, since the studio of the martial arts is small and we do not want to have spaces that are blank and are not used, whenever it's the places are alternating they're alternating. It's either you are doing randomly the push-ups in the area of the mattresses, or either you're sitting near the wall in a row after you finish. But those places are like interchangeable. There is no empty spaces that is left. As if everybody is already sorted near the wall, so there is no more place left in the area of the mattresses. It's either or. So it's kind of shows that as the area of things that are sorted expands, so the area of things that are not sorted is shrinking. And I actually kind of fooled you a little bit. When I made this arm maneuver, and I did this kind of maneuver here like this, when I did this swapping, I actually did not tell or reveal the whole truth. Because actually, when we are making a swap in programming, we cannot make this kind of maneuver. We cannot just simply swap objects one with another, and we cannot do that. And the reason that this is not possible in computer science can be explained with an example. When I am walking on the street and I feel a little bit chilly and I want to put on my coat, but I have my purse, my woman purse on my shoulder, I cannot do both things together. So I can approach my friend that is standing next to me, my guy friend, and ask him if he can be considerate and hold my purse for me. And he may not like it that much to walk around with my purse for long, but he will do it nonetheless, at least for a short while, until I can put my coat on. And with computer memory, it's quite the same, because memory, the reason that I gave my friend and asked him to hold my purse for me is because I could not just put this purse in the air. If I would just leave it there in the air, it would fall. The air would not hold that purse. And it's quite the same with memory of computers, because memory and information, until according to the technology that is available today, cannot be remembered on using air alone. We need some physical device to hold it, whether it will be a USB stick, a flash disk, some chip, or whatever, a physical object that can hold that information. And if it wasn't this, it would be very cheap to store data. But we still need to go and to buy a storage location with money and pay for it, because it's not air, it's something physical. And a way to show it and to explain it, I can tell you an example that will illustrate it. I have a niece, and she's very sweet, and as she came to visit me, I prepared her favorite drink, which is a cup of milk. And to myself, I rather drink some coffee. So I put a milk to her in one glass and a coffee to me in a second glass. And she began to be very angry and to cry. And she complained, and very rightly so. I completely forgot that my niece's cup is a cup that has a heart on it. And I forgot. And by mistake, I poured my coffee to the cup with the heart, and it was supposed to be my niece's cup and not mine. So my niece insisted that I make this adjustment and move my coffee to another cup and to put the milk in her justifiably so cup with the heart. And when I take those two cups, which one has milk and another one has coffee, and if I want to swap them, there is no way I can do it simultaneously like that, in the same way that I thoughtlessly did it before when I did this. When I positioned my arm this way. I cannot do it. And the only way I can perform this swap is to take a third cup. I can, in my code, I can present a new variable that will make this assisted will assist this swap. And what I will do when I am taking this other cup used as a swapping space, I'm going to take one of those cups. It doesn't matter which one. Let's say I will take the cup with the milk. I will pour it in this other temporary variable. Now I will take the cup with the coffee. I will pour it in another cup. And here I have this cup of my niece with the heart on it. I can return the milk to it. And now my niece will gladly drink her milk from the cup that she likes, that has a heart on it. And this is how we perform this swap. I hope my explanation about selection sort was interesting and informative. And thank you for watching. Give a like.